All right, let's talk about something that keeps our world from literally crumbling around us. We're going to dive into the hidden science of microscopic armor, this process that protects massive metal structures. It's absolutely critical, but almost completely invisible. So let's get into it.
I mean, really think about it for a second. You've got these gigantic pipelines, massive refineries, super complex machinery. All of it is made of metal, and it's all exposed to the elements, day in and day out. So what's stopping all of that from just turning into a giant pile of rust? The answer, it's not just a simple coat of paint. It's actually a pretty sophisticated chemical trick.
But before we get to that amazing solution, we have to really understand the enemy. And this enemy is a relentless, destructive force that, honestly, it never sleeps. We are talking, of course, about corrosion.
And look, this isn't just about making things look pretty. In high-stakes environments like the energy sector, a corroded pipe or a faulty valve can lead to a catastrophic failure. We're talking about huge safety risks, environmental disasters, and just massive financial losses. So the bottom line is this: preventing corrosion is totally non-negotiable.
So how in the world do you fight back against a natural process like rust? Well, it turns out you don't just block it. Instead, you actually enhance the metal's own natural defenses to create something pretty remarkable.
The solution has a name. It's called passivation. And what it is a chemical process that basically supercharges a metal's own ability to protect itself. So instead of adding a layer on top of the metal, it actually transforms the very surface of the metal itself.
And this right here is the core idea. Passivation forges this invisible shield made of chromium oxide. It's incredibly thin. I mean, we're talking microscopic, but it is also incredibly tough and non-reactive. This is the passive layer that stands between the raw steel and everything in the environment that wants to corrode it.
So that's the key question, isn't it? If stainless steel already has this natural ability, why do we need this whole special process? Well, because that invisible shield, as tough as it is, can definitely be damaged.
You see, the shield gets compromised pretty much any time the metal's surface is disturbed. Welding, for example, heats the metal up, and that can totally disrupt the oxide layer. Even just cleaning it with the wrong tool can scratch it away. That's exactly why passivation is such a critical step for brand new equipment after any kind of fabrication, and especially after any serious maintenance. It's kind of like restoring the force field after it takes a direct hit.
Now, creating this shield isn't some one-size-fits-all kind of deal. It really requires the right chemistry to get the job done both effectively and safely.
Okay, what's really interesting here is the choice that technicians get to make. For years and years, nitric acid was the go-to. It's super powerful and it gets the job done, no question. But now, citric acid is really gaining ground, and believe it or not, it's derived from things like lemons and oranges. It offers a much safer, much more environmentally friendly way to get the exact same powerful, protective result. Pretty cool.
So I want to be clear, this isn't as simple as just dipping a piece of metal into a bucket of acid. Passivation is a science of precision. It's a meticulous craft where every single step matters.
The process itself is very methodical. First up, the surface has to be perfectly clean. I'm talking no grease, no dirt, absolutely nothing. Then comes the acid treatment. After that, it gets rinsed completely to wash away any residue. And finally, the part has to be handled super carefully to avoid contaminating that brand new invisible shield.
And this quote right here, it really gets to the heart of the matter. It's not just about following a few steps, it's about mastering every single variable, the right chemicals at the right temperature for exactly the right amount of time.
So yeah, the crucial thing here is mastery over all these little details. The concentration of the acid, the temperature of the whole bath, and how long the metal is exposed. If you get any of these wrong, that protective layer just won't form correctly. It is a very delicate, scientific recipe for making something incredibly durable.
So, you've gone through the whole process. The shield has been forged. But how do you actually know it's there? I mean, how do you test for something that's literally invisible?
Right, because in these industries where failure is simply not an option, you can't just cross your fingers and hope for the best. You have to prove it. Verification is an absolutely essential part of the quality control process.
Well, technicians use several pretty clever methods. Some are really straightforward, like the water immersion test, which is basically just seeing if it starts to rust. Others are more complex, like the copper sulfate test, which actually causes a color change on any part of the surface that isn't properly protected. And for the highest level of assurance, they can use advanced analysis to inspect that shield at a microscopic level.
And finally, the last step for quality assurance. is that everything gets documented. Every step, every chemical concentration, every single test result. This creates a complete record that guarantees the job was done right and that it meets all the industry and regulatory standards.
So when you pull it all together, from understanding the threat to mastering the chemistry and verifying the result, it all comes down to one single thing: creating the strongest possible defense against corrosion to make sure our most critical infrastructure is safe, reliable, and truly built to last.
It really gets you thinking, doesn't it? We rely on countless systems every single day. So if this is the science that protects our steel, what other invisible engineering marvels are out there, quietly and constantly at work, keeping everything else from falling apart? Something to chew on. Thanks for tuning in.